So my name is Jussi. I'm from Team Kontena here. Today I'm gonna go through how to run your Dockerized services across different cloud providers, where you actually have the same kind of sort of cluster setup that actually spans multiple different cloud providers. And I'm gonna actually demonstrate how to even plug a private data center into the same cluster. Well, private data center being Vagrant in this case. No, this doesn't work. So the agenda for my presentation is basically, I'll go through Kontena really briefly. I guess that most of you know what Kontena is all about already, but I'll just have a quick kind of a recap. What's Kontena all about? Then I have a few slides that describes the overlay network and the concept of the overlay network that we have. And not only we have, but the sort of overall concept of any container overlay networking. And then of course run a live demo. So let's hope that works today. Let's see. So Kontena really is an open source container and microservices platform, and the focus is really on providing the easy to use features to enable developer happiness. Basically, make your life easier. There's quite a lot of sort of installs of our components. For example, yesterday I checked from the Docker Hub that our agent image is actually being pulled already over 1 million times from the Docker Hub. So it gives you some impression that it's actually quite widely used already. And we've been featured in New Stack. The Black Duck organization selected as Open Source Rookies of the Year in 2015. And then we've been marked as or selected as sort of a open source company to watch in the CIO magazine, for example, lately. We've been getting quite a good feedback from the community, and especially the middle one is the one I like the most. We actually got that like a couple of weeks ago. One of the users in our Slack just sort of popped into the Slack channel and said, okay, hey, I'm working on day 2 with Kontena and I'm rolling things into production now. I mean, day 2 rolling into production with a new platform. I mean, that's just something at least. So in Kontena, the most important concept that we have is the grid. So that's the sort of cluster of your machines, whether they're virtual, bare metal, somewhere, it doesn't matter. And we basically take set of your machines and combine those as one sort of big Docker engine, kind of. On top of the nodes, we automatically create the overlay network, which I'll then dive deeper pretty soon. And on top of the overlay network, we have service discovery based on DNS addressing. And also there's etcd available for this sort of a key value based services, more like custom service discovery if needed. And then we do, of course, the actual orchestration of your services. We make the decisions that where to run your service instances, what to do if one of your node dies, we reschedule your services and those sort of things. And of course, the topmost in the layer is your workload, your containers, and your applications. So on node level, what happens is that the Kontena agent is running as a Docker container. Of course, it has to have some more privileges to be able to control the Docker itself under it. And that's about it that you have to kind of install. All the other bits and pieces that needs to be running, set up like the overlay network, the agent manages that for you. So you don't actually have to do pretty much anything after the agent is in place. And the sort of the brains of the system is the Kontena master And so when the agent boots up on the node, it calls home to the master, and then the master is giving all the instructions that what the agent should be doing. So the agent itself is sort of a stupid in a sense that it doesn't make any decisions of his own. So all the instructions come from the master. And of course, you can set up the master in HA setup, so you can actually it's basically REST API. So you can have multiple instances running, and it uses MongoDB as the sort of persistent state. So it's pretty easy to replicate MongoDB. As I said, it's REST API, so you can basically integrate anything with it. We of course provide the Kontena CLI tool, which then just talks with the REST API also. And we've just published the REST API documentation also, so it should be online already. So if you want to integrate something, it's pretty easy to follow. We do have quite a lot of sort of batteries included, so it's just only not about the orchestrating the containers itself, because that doesn't bring much value for application development, because you need a bunch of other things that you have to solve. So for example, we provide built-in image registry for your private Docker images. We have even a VPN access point for the overlay network. If you want to, if you need to do some database maintenance things, or debug some networking issues or something, you can just take a standard VPN connection and you're within the overlay network. We have a load balancer. Of course, you want to run multiple instances of your application, so you want to have load balanced across those instances. So that's out of the box also. We collect the statistics and logs from your containers, so you actually have one single place to access the data. So you don't have to go with SSH to some random node and try to find your application instance and try to find the logs and then to do some scraping, and you know the drill. You don't want to do it really. At least I wouldn't want. We have, of course, user management. So all operations towards the master REST API is always authenticated and authorized. And all the actions that cause changes in the grid, changes in the services, we collect the audit trail log. So there's clear line of sort of what happened when and by whom. Because we always want to know the guy who to blame, right? And we also have a built-in secrets management, so you can actually securely store your database password, for example. So you don't have to configure it to your Docker image or plain text in any configuration file or anything. So the vault has everything. While the secrets are at rest, it's always encrypted. And then when it's going towards the agent, it's always within the TLS tunnel. So it's basically secure all the way up to the final point where we actually inject into the container environment. So pretty much all the crap you don't want to build yourself anymore nowadays. I mean, don't get me wrong, it's fun to build things like this, but it's probably not the sort of business value for you to build these things. Okay, so that's really short recap into Kontena platform. Wow, I think I made a record being that fast. So what about when you want to deploy things in a sort of multi-cloud, multi-data center fashion? So what are the typical problems that you would face? I mean, whether you do it with containers or sort of traditional way of using Ansible, Puppet, or whatever you use. So there are a few issues that you typically would bump into. there's always going to be differences in the deployment, how you deploy things, how things are run, because the platform is different, the infrastructure is different. For example, the networking configuration within every single cloud provider is quite different. So your deployment automation or scripts or whatever they are, they need to take those into account. So you actually have to do quite a lot of scripting and intelligence into that part. Then how do you enable connectivity between the different clouds? I mean, you don't want your application backend running on AWS to talk to your MySQL running on Google Cloud. You really don't want that to be unencrypted traffic, right? So you have to enable security and connectivity between the cloud providers. And then how do you discover your services? I mean, how do your application provider actually, or application instance, know that it actually has to call the MySQL in the Google Cloud? So you have to build that sort of a intelligence also pretty much by yourself. Those are just some examples. There's plenty of other road bumps in the way also. Of course, you could build VPNs between the different clouds. We've seen that. I've built those in the past. And you can, of course, provide custom service discovery mechanisms like some console or something. And then if you are using, let's say, plain Docker, you would have to do quite a lot of port mappings between the exposing ports from the containers. And if you've been doing that in the past, you know that it's sort of, how to put it in English, it's karkaa käsistä, lähtee lapasesta. I mean, it gets out of your hands pretty quickly. You're exposing this port here, this port there, oh fuck, they are clashing. What do I do next? And those sort of problems. Yeah, been there, done that, never again. So that's where the overlay networking comes into the picture. And maybe I should say advanced overlay networking. So the idea is pretty much that you create a network that actually spans across these different data centers, cloud providers. And when you launch a container somewhere, it's always attached into the overlay network. So regardless where it's actually running, you can access all these containers through the overlay network basically as in local subnet. And all the hassle and difficulty of setting up the connections between the cloud providers, security and all those things, it's sort of abstracted away on the networking level. So your container doesn't understand anything about the overlay network. It just connects to another container with an IP or DNS name, and that's it, just works. And with, for example, with Weave networking, which we are using, you can then expose existing internal systems into the same overlay network. So let's say that you have the legacy Oracle running in your basement somewhere, which you just have to have because it has valuable data and the business guys don't want to get rid of it or something. So you can actually use the Weave network so that you can attach the Oracle machine also into the overlay network. So basically it means that my container in AWS can actually access the Oracle with an overlay network IP address without actually realizing that it's actually running on your private data center somewhere. So some of the sort of main features that we have in the Weave overlay network that we use with Kontena. So it's sort of a mesh type of network that it has. So basically you have a set of peers connected to each other, and you can do this mesh type of routing within the network. So not all of your nodes need to be able to connect to every single node. So you can have these multi-hop routing things. Of course, that means latency issues, probably some throughput issues. So your application and your services have to be able to sort of survive in that sort of an environment. But it's anyway a really cool feature to have. So that, for example, your private data center node doesn't have to be able to connect to every single node on the cloud. It just needs to be able to connect one node, and then you can do multi-hop routing from there. As said, there's also a DNS available in the overlay network. So basically, whenever you spin up a service, whenever you spin up a container, it gets DNS address. So your service discovery doesn't, well, it cannot be much easier than that anymore. Your web app finds MySQL also always using the MySQL DNS name, regardless where it is running actually. Encryption also happens on the network level. So when two of your services, your containers want to talk to each other securely, you don't have to implement TLS or anything on the application level anymore. So you can just rely that okay, you send packets to the IP address and it's always encrypted. Strangely enough, it supports even multicast, which is, or well, it's a really cool feature, although not that many products use multicast anymore, that widely at least. We used to use quite a lot of Elasticsearch in the demos in the past, in this sort of a multi-cloud setups, because the older version of Elasticsearch had that UDP multicast discovery thingy. So when you spin up a Elasticsearch, it's starting to send UDP multicast, and whenever it got replies, the Elasticsearch cluster formed automatically. But the guys at Elastic, they just, for some weird reason, they just disabled it, removed it completely from the new release. I don't understand why, but because that was really cool to demo that okay, I have nodes running DO, AWS, Vagrant, and I spin up Elasticsearch and its cluster is working. That was really cool. And what's really important in the cloud world is the network address translation, so that it actually works over the NATs also. So basically, what happens in the network part, your application is connected to some other application or container. So basically, the web router sort of intercepts the packets in the kernel space on Linux. It of course then starts to modify headers of the packets and whatnot. And then of course it figures out that okay, the packet is going to an application on this node, so it's able to send it to another router on that node, which then of course does the sort of reverse translation kind of thingy, and then injects it back to the kernel, and it's then going directly to the container, the destination container. Yeah. So basically, each node in a Kontena grid, or if you run Weave on without Kontena, so each node in the setup is called a network peer. And the peers themselves then establish TCP connections between themselves, between the other peers, and they then use that connection as the sort of control plane of the network. So they exchange information about the other peers and exchange information like, okay, I know these containers and their IP addresses. If you have packets for them, give them to me, and that sort of an information. Like you have in traditional other networks also. You have these ARP protocols and whatnot. I'm not a deep network expert, but anyway. And then they also established this sort of a UDP connections between the peers as the sort of a data plane. So the data is always going actually on top of UDP. And then the weave itself configures itself as the network bridge on each host. So yeah.
So with UDP, you have some extra system
yeah, it's the weave itself that takes care of the UDP sort of issues or potential issues. Yep. So whenever you spin up Kontena or weave by yourself, you'll see that there is a network interface, network device called weave configured on the host. And then all the containers that are attached to the weave network, they are then of course connected to the bridge with these VETH pairs, so that what you have on the container side, the network interface is actually bridged into the weave bridge interface. And then, as I said, the sort of network topology and the container info, like the MAC addresses and whatnot, they are then exchanged between the peers. So the peers talk to each other always and exchange information and keep up with the possibly changing network topology and other stuff. The weave overlay network supports actually two different modes of operation. So as the name implies, the faster one is called a fast data path, and the slower one is called sleeve. So basically the big difference is that the fast data path uses actually only kernel space forwarding with Open vSwitch and the VXLAN capabilities. So it's pretty fast. I mean, it's near native performance given with the right configuration. Let's put it that way. And then the sleeve mode is most of the work is actually done on user space on Linux. So of course, naturally, that's quite a bit slower. I've actually forgot to put the most important differentiator in the slide. And the differentiator is that the fast data path cannot be encrypted at the moment. So when you have connections that you want or have to encrypt, you have to use sleeve at the moment. The Weave guys are actually working on that as well, kind of as we speak, and they have already some release candidate how to do the encryption also quite a lot more effectively. Then the IP address management for your containers. When using Kontena with Weave, the IP address management functionality is actually taken care of by Kontena platform. So we do have one infrastructure service running on each node as a container, of course. So whenever you spin up Kontena, you'll see on the host node that there is a container called Kontena IPAM plugin running. And the data is actually backed up by the etcd that we already have in the Kontena cluster. So it's kind of like DHCP. Of course, it's not any RFC implementation or anything, but it's kind of, when you spin up a new container, Kontena platform asks the IPAM plugin that okay, give me an IP address, and it uses that. The default overlay network is this 10.81.00/16 block, and it's actually divided into two different sort of areas or subnets. So the lower half is actually used by the Kontena itself for the sort of infrastructural services, for the nodes themselves and things like that. And then your containers are spun up in the upper half of the block. So basically, you'll see something like this 128 dot something for your container IP addresses. As said, the overlay network has its own DNS service. And what Kontena provides is the sort of configuration for the DNS. So whenever you spin up your services, your containers, they always get a DNS address. And what's kind of nice about it is also that the sort of service level DNS has all the IP addresses of the service instances under it. So it's kind of an alias. It's not a CNAME alias, because the DNS doesn't support CNAMEs. Otherwise, I guess it would be a CNAME alias. But it's this sort of a round-robin list of your service IP addresses or instance IP addresses. How the DNS is always configured is that you have this service.stack.grid.container.local for each service that you spin up. And then of course you get this service-instance number .stack.grid. And then when you expose your services from the stack, they are sort of promoted into this grid level DNS. So then it gets a DNS. If let's say that I deploy a stack called web, and I have some Nginx running in there, for example, providing static web pages, and I expose the Nginx out of the stack, I would get the web.grid.container.local DNS address name also for that. Cool. Any questions at this point before I dive into the demo? Yep.
What if I don't want to use different cloud providers? Do I have to pay these penalties or these penalties?
With Kontena, yes. I mean, with Kontena, the overlay network is always there, because it makes your life much easier, even though when you are running in one single cloud. But when you configure things properly, the penalty is not that bad. Because without the overlay network, we would have to or you or Kontena would have to actually do the port mapping dance and all these other shenanigans to get things properly connected to each other. So
I'll be your audience questions host, so hold on to your beer can when I throw if you're gonna ask a question.
Yeah, so we did some testing with Docker in Azure, and we really had some issues with latency between nodes. And I hope with this system, there might be it might resolve some of those issues, with especially with the fast DP. So are there any kind of comparison tests or done with regarding from node to node connectivity with and without this?
On Azure, I don't recall anybody done any testing, at least on our team. I've actually run some ran some benchmark yesterday on AWS. They were pretty okay. I mean, I used the of course, I'm running things on a demo mode, so I don't want to spend too much money on any of those Amazon big boxes. Because in Amazon, for example, I'm not sure, I don't know Azure that well, but at least in Amazon, the basically your network sort of native network performance is it's comparable with the VM size that you want. So basically, when I use small VMs, I don't get that much network throughput anyway.
You want not say like bandwidth, I mean like the latency.
Ah, the latency. Okay. I think I tried yesterday and I didn't see much difference, at least on Amazon. I didn't see much difference between the basic ping times between different nodes.
Hi, could you say something about reliability when things go wrong, or when
Things don't go wrong in cloud.
Things always go wrong in cloud.
Yeah, I know.
Something, for example, when the Weave network misbehaves or something, like you can't locate other nodes.
Yeah. Weave itself is, I would say that it's quite stable. So we haven't seen it crashing that often. We've seen it crashing, of course, a few times, but we haven't seen it crashing like every other day or something. And most of the issues that at least I recall seeing with Weave and nodes not finding each other is typically caused by kind of configuration issues on the node level itself. Like, for example, we had some issues with the latest CoreOS stable, or was it the one before that? I don't remember which version it was. It shipped some weird default network configuration that actually just broke Weave down. But it's not a Weave and overlay problem itself. So I'd say it's quite reliable. But then again, it's software, so. Okay. For the demo, what I'm gonna spin up, I have the master running already on AWS, and what I'll actually do, I'll spin up a three Kontena nodes on Amazon. So this will be my sort of initial grid. Then I'll expand the grid on DO. Why it's flickering so annoying. And then as the last step, I'll put one node in a private data center, my MacBook, and we'll see that things just work. Hopefully. Yeah. Okay, cool. Just check that I'm connected to the master that I'm supposed to be connected to. I have this sort of a cheat sheet, a couple of commands. So because I know that I'm gonna spin up the nodes in my default VPC in my Amazon. So I know that I've already checked that, okay, that's the default subnet in my VPC. So I already, before spinning up the nodes, I can of course already say that, okay, this will be the trusted subnet for the Amazon nodes. And before that even, let's check that I'm using also the correct grid. Yes, multi-cloud seems about right. Oi. Yeah. Yep. So now basically the grid sort of object on the master is now configured with this trusted subnet concept. EU Central 1, 1A, default VPC, provisioning, testing, small, yeah, 3. Okay, so the plugin takes care of the rest. You can, of course, configure these trusted subnets afterwards. And the Kontena agent should be able to pick that up automatically and reconfigure the Weave network if needed. Go on, last guy, go online. It always takes up a few minutes because the node actually, when it starts up and the Kontena agent starts up, it has to actually pull quite a few different Docker images. So that's the part that takes actually the time. Okay, well, it wasn't that bad, right? We actually configured 3 nodes, so. And then on the node listing, you see that okay, we populated all the regions and everything. And now when we have the trusted subnet configured, so whenever let's check, for example, the first node. Yeah. Minus A. Yep. Now I'll copy paste one command to check the basically ask from Weave that okay, what's the status of your peer connections? As you can see, it's unencrypted fast data path because we configured the trusted subnet. So all this information, and as you can see, it's really using the VPC private IP addresses also, because we have the region label and Kontena is intelligent enough to have use the ETH1 connect interface between the region or within the region. So we didn't have to do much configuration to get this far already. Okay, let's deploy something. What do we want to deploy? What? Yeah, let's deploy it. Anyway. Okay. Quite straightforward, right? Once that's deployed, let's move to a further and take DigitalOcean into the picture. again, we are waiting Docker to pull the images, basically. I think we've been internally discussing that we should make a private Amazon image that has all the images built into all the Docker images built into the Amazon image that we use typically in demos, because it's just annoying to wait. Yeah, well. So we've created 3 instances and deployed 10 instances of Nginx in a few minutes. Okay.
Want to start the distribution of those Nginxes across
Huh?
run LS for the services, so that it's simple distribution.
You mean this?
Just so we're there.
Yeah, well, it's now evenly distributed across the Amazon instances. Of course, if I would be setting up a production type of system, of course, I would have put all of these nodes into different AZs, of course. It doesn't make sense to run things on one AZ only. We all know that Amazon AZs can go dark or power off unexpectedly, so. Okay. Let's use Frankfort because it's actually the Amazon region I used is actually also Frankfort. So let's use the small ones. Let's create 2. Okay, and again we are waiting. Notice that I didn't actually create any trusted subnets for the DigitalOcean. And that's because DigitalOcean doesn't provide trusted subnets. They do provide this private networking for your instances, but it's actually shared private networking. So I don't want to send any data unencrypted over that. And to cut down the waiting time, what I'll think I'll do is let's put this guy to work also. Yeah. Let's see what happens. When new nodes are joining the grid, I'll make it a bit bigger. So when new nodes are joining the grid, Kontena master will start to figure out that, okay, there are new resources, new capacity in the grid. And it actually might transfer some of the services, some of the instances to run on the new nodes. So what we should see in few minutes when the nodes are online, we should see some of the instances actually being sort of moved to the new nodes, joining the grid. Okay, you see now that it's already deploying. And it went down to 9 instances, so it's actually moving one of the instances now to some other node. Let's see where it lands. Yep, it landed on Misty Moon. Sounds like a porn actor to me. And all of this is, of course, fully automatic. I'm not doing anything. It's the container master that's making all the decisions for me. Whether it's good or bad, I mean, I don't know. Which one was the Misty Moon? On DO. Oh, okay. I'm not sure why it put 5 there and the Vagrant, of course, is the slowest one. Yep. Mm-hmm. So when you're provisioning new nodes, so the provisioning plugin would send a webhook, right? Or okay. Currently, we don't have that. Of course, feel free to open an enhancement issue, and we'll see whether to build it or when to build it. Not whether or not to build it. It's always a question of when to build it and when somebody has enough time to build things. Okay, Vagrant is also now up and running. The Vagrant node is Silent Snowflake 92. I think we should see some of the instances running there also. Let's hope so. Now if I get the status connections, so what you can see that the nodes on the DO, so this one where I'm at SSH on, that's the node on AWS. So it's connected also to the DO nodes, but it's encrypted with the sleeve protocol. And this one will actually be forever in connecting state, because that's the Vagrant node. And of course, a node on Amazon cannot connect to my Vagrant node, because I haven't I haven't been doing any port mappings on Vagrant or anything. So I just cannot connect. Okay. So Misty Moon is on DigitalOcean. Misty Moon. Okay, so the Nginx instance number 8 is actually running on the Misty Moon node. So and let's check the IP address in the OLA network. So it really works. And as you can see, I'm now actually hopping from Amazon to DigitalOcean encrypted. So the latency is actually not that bad, I'd say. Yeah, of course, they are close by, of course. So it's not that bad.
Can you try pinging the actual public IP of the node itself and see what the minimum latency without leaders?
Of course. It's not that bad on the latency front. It's like 30% or something on that ballpark at least. Of course, if I would be running another node on Frankfurt and the other one in Japan, the story would be totally different, but that's just the fact of, well, the light has to travel quite a long distance, so there's physical issues also in that sense.
Yes,
in the
that
flight.
would be helpful with proprietary like
Dedicated cables and
not dedicated cables, but dedicated connections.
yeah, yes, of course.
Something we use with China.
Okay, it's cool.
As you know, the public that might be.
Well, I don't know, but I can guess. Okay, so now automatically also my Vagrant has something running. Which one was the Vagrant one? Silent Snowflake. Oh yeah. Dash IP. What?
Got the same thing for your other. Yeah, that's it. I look really different.
This one is easier way. This always works. Now if I again ping the, what was the IP address that I pinged? Something running on DO. It works for my Vagrant also. So basically all the containers on all the data centers and all the nodes can actually talk to each other. Of course, now you see the latency because I'm well, you're Finland and the other one is Frankfurt and cool. So that was surprisingly easy to set up right. And it worked. It worked as expected. Any questions, anything you want me to show, demo around the connections or anything?
Do you have control to anchor you have some control to anchor the containers at least? For example, if you want the DigitalOcean to the Nginx, for example, you want it to run on Vagrant. Can you can you anchor it to there?
Yes. So what I could do is I could say that what? J Wilder. What's that? What's the syntax? Oh yeah, something like this. Let's see if this works. I mean, probably I'm making some typos on the syntax, but anyway. J Wilder.
Yeah. J Wilder dash. J Wilder / will
Like this. Any ports?
Yeah, it's HTTP server response with the host name.
Do you remember which port? Okay, let's put it on the host side. 8,000. Okay. So that should actually now land only on the Vagrant node, because I've said that okay, deploy this service only on nodes which has this provider equals Vagrant label. Of course, I could have said that okay, deploy this one only to a node which name is the Vagrant node. But of course, using the labels, that's more flexible. Because that way I can say that, okay, deploy this only to my private data center, regardless of how many nodes you have there, or deploy this only to DO or whatnot. Or you can have also negations on that. So don't deploy this on my private data center. Or okay, so you can actually see that the whoami is running on the Vagrant node now. $8,000 was the port, right? I'm silent snowflake. Yeah.
Next question, can you just run it as an actual content service and then deploy a load balancer on DigitalOcean?
Of course.
So you can use the public IP of the DigitalOcean node, so through the load balancer and get into your local Vagrant. Yeah, so to summarize, because if you have a node running on Vagrant, you don't really have a public IP address. You can't accept incoming connections to Vagrant. But if you have the overlay networking from your local Vagrant node to something in the public cloud, which does have a public IP address. If you can deploy a service on Vagrant, and then you have a load balancer, Kontena load balancer on the public node, and go through the overlay network to access that load balancer.
Yep.
You should probably pin it to.
Oh yeah, I should have.
Well, if it lands on the public node, it should be okay.
Yeah, let's hope. Okay. Let's see where it landed. Polish do. Well, it's not it's not the Vagrant, so it should be okay. Oh, freaking Christ. I forgot to expose the port so that I can actually get into the load balancer. Okay, it's done. Who am I? I'll have to link it to the load balancer so the Kontena actually starts to configure the load balancer for this service.
NetBridge, probably. NetBridge.
Oh yeah. Bridge. What else do I need?
Internal port. Internal port 8000.
Ah. Kontena LB internal port equals 8,000. So it means that within the overlay network, the load balancer directs the traffic to the 8,000 port of the service. It defaults just to 80 port, so I have to tell it explicitly. That should be.
You already have the whoami.
You
already have the whoami to start.
Of course, you really should do these modifications in a more controlled manner and not just randomly use the stacks, really. And it helps if you know how to type. I don't seem to. Let's see what happens. Okay, everything's updated. So now when I check the load balancer, check the public IP address of the node, hit it with my browser. So I'm actually hitting a node on a digital ocean, which then directs the traffic or proxies the traffic to my Vagrant, which actually doesn't allow incoming connections from the internet. Pretty cool. So that's really the power of overlay networking. And everything is, I haven't been configuring that much of things.
Yeah. This is the NAT traversal that we talked about in the overlay networking. So Weave is able to work even if you're able to establish, as long as the Vagrant node is able to establish an outgoing connection to any of the other nodes, it'll work in both directions from everywhere.
Yep.
So now if you kill the Vagrant node, what happens next?
Let's see.
Power off.
Of course, I'm not getting anything, any replies anymore, because no node went away. But no, Kontena doesn't move the service anymore anywhere, because we pinned down it to only to run on nodes with Vagrant. If we wouldn't have had the affinity rule, Kontena would actually now figure out that okay, we got the service got lost, and it would actually automatically redeploy it to some other instance, some working instance. So if I would have actually now second Vagrant running, Kontena would be able to move that whoami service to the other Vagrant node, because it has the same label.
So it's been another Vagrant before.
Yeah.
Which you know.
Yes. Can you trace any other test cases?
Well, you can spin up the second Vagrant node.
Well, let's do it after more beers. Success. Any questions, comments, insults? Just raise your hand and Tero will throw you the mic.
What if I want a host name for that and not an IP address?
Host name for the other IP, which IP address?
I would just want a domain name, multiple domain names for one IP address. I don't know where it's going. I have a service.
You have a service, yes.
Yes, I have multiple services.
Multiple services, yes.
Yes. I have the IP address. I don't know where it's going. When I
Weave, you mean? Or
You mean HTTP request mostly? You mostly HTTP virtual host.
yeah.
maybe my head is going too slow.
Isn't that handled by Nginx or Apache or something?
Yeah, that's handled by the load balancer.
Yeah.
So basically, you can say that okay, if I have let's say I have a demo.example.com as my host name.
Yeah.
So you configure that to the load balance or to the service that is load balanced. So what I would actually have to create is or do is or I have too many windows open. So now I just configured that, okay, the path for this service is this / only. So I could have actually configured it like this also. Like this. Yeah. So now the load balancer HA proxy gets configured that, okay, whenever you see traffic to demoexample.com, give it to this service. And when I sorry, when I didn't configure anything about the balancing rules, by default it uses round robin. And of course, whenever I spin up new instances of the service, whenever I scale up my service, let's say 10 instances of the whoami service, the load balancer is always automatically updated. So it right away, when all the new instances start up, they get always automatically configured to the load balancer and get traffic. Of course, you can use sticky sessions, source stickiness, cookies, whatever you need to use, if you want to keep the traffic from one client to the same node always. Any other questions? Everybody too thirsty already? Well, that's our mission, to become really the #1 container microservice platform for the developers. And that's where you guys can, of course, help us. It's an open source project, so give feedback, do pull requests. Whenever you see, for example, something that should be fixed in the documentation, for example, just feel free to fix it and make a pull request on GitHub. And of course, join the Slack channel if you haven't already. That's where you can ask questions and get feedback, and of course, join the meetups. That's it. Thanks.